Today we're in section 5.1. Sorry for my voice sounding so rough. Today we're in section 5.1, rational numbers. All right. Several examples today. We're actually going through 6 examples. Some will go quicker than others. Your homework tonight is about 28 problems. However, I think 24 of them don't even require you to show work. We're simply converting back and forth decimals to fractions, fractions to decimals, dealing with mixed numbers. So it should be pretty straightforward, especially after we work through these examples. The first thing you need to know, though, is the definition of a rational number. A rational number is a number that can be written as a quotient of 2 integers. What does that mean? It means we can write it as a fraction. Whole numbers and integers are, yes, part of this. What is not part of it is decimals that go on forever, they do not terminate, and they have no pattern, they don't repeat. Those are irrational numbers. Okay, so you're going to have 2 sections on your homework tonight where it asks you to show that the number is rational by writing it as a quotient of 2 integers. What does that mean? It's a fancy word for fraction. Write it as a fraction. How do I write a whole number as a fraction? 7 over 1. It's that easy, okay? All I'm doing is showing that it's rational, okay? So I want you to do the same thing to the second one. Okay, so I just have the question, can it be negative? Yes, it can be negative. However, the negative has to be attached to numerator or denominator. It cannot be in front of the fraction. It's got to be either attached to the numerator or the denominator. Doesn't matter which one. Now on the third one, I need to change this to an improper fraction, and then it will be written showing that it's rational. Okay, so what's it going to be? 23 over 4. All right, now, with a negative fraction, it's important that you pay attention and listen to this. With a negative fraction, I'm going to convert the mixed number, ignoring the negative. So 3 times 2 is 6, plus 1 is 7. 7 over 2. Now I'm going to either attach the negative to the numerator or the denominator. Okay? Whoever's whistling, you need to stop, please. Okay, so that's how I show that a number is rational, by writing it as a fraction. Like I said, you have 2 sections like this on your homework tonight. Guys, there's no math. All you're doing is just rewriting it. All right, now let's talk about, for a minute, terminating or repeating decimals. A terminating decimal is a decimal that simply ends 3.2. A repeating decimal is a decimal that continues on 2.56, and it does not end. And I show it using what we call bar notation, just a fancy word for the bar that occurs over the numbers that repeat. All right, so in example 2, I'm converting the fractions to decimals. Now, this is an example because the book technically wants you to do it by hand. However, I am going to allow you to simply use your calculator to convert these fractions. Get out your calculators. Okay? Get out your calculators. Calculators, enter the fraction. Stop talking right now. Enter the fraction 3/8, hit equals, shift S to D. Enter the fraction 3/8 with your fraction button, hit the equal sign, shift, and then hit the S to D button that's above the delete button, and then it will change it to a decimal for you, if it didn't already change it when you hit the equal sign. Some calculators do one or the other. All right, so what did you get? 0. What is it? 375. All right, go ahead and change 5/11ths to a decimal. Okay, you don't have to hit the shift button. After you hit the equal sign, you should just be able to hit the S to D button. Sorry about that. All right, so 5/11ths as a decimal is what? 0.54 repeating, and both digits are repeating, so the bar goes above both. All right, now we're going to do mixed numbers as decimals. All right, back it up. 45 repeating. There we go. All right, let's move on. Okay, so now mixed numbers. Guys, where does the whole number go if I'm writing it as a decimal? Where does the whole number go? Before or after the decimal? Before. Okay, so you don't even have to include that in your calculator. Okay, you know that that's the whole number. Now, change the fraction part to a decimal. All right, 33 over 100 as a decimal is 2.33. Okay, so the 2 was already there because that was my whole number. I want you to try 4 and 2/11 as a decimal. Going to be 4.18. And now which numbers are repeating? The 1 and the 8. So repeating sign goes above it. Okay, and we'll box it in. All right, so that's how we write fractions as decimals. Now in example 3, and you have 2 of these on your homework tonight, I need to read the word problem, make them into fractions. Okay, so I need to use 2 fractions. I'm comparing them. And then there's several ways that I can compare them. All right, so let's read it. It says, of the 50 mammal species found in the Canyonlands National Park, 20 of them belong to the order Rodentia. Of the 54 species in Badlands, 24 belong to Rodentia. So in which park is the fraction of species belonging to Rodentia greater? All right, so I need 2 fractions. What's going to be my first fraction? Andrew? 20 over 50. What's going to be my second fraction? You can answer 24 over 54. All right, now there's a couple options. I could reduce these fractions to make it easier to find an LCD. I could try to find an LCD here, but my LCD is going to be just enormous. Or those really aren't that appealing to me because they do require a little bit more work. I could just convert these to decimals. Convert them to decimals. I don't have to reduce anything. All I have to do is convert both of those fractions to decimals. All right, so what did I get when I did 20 over 50? Okay, 4/10, very good. And 24 over 54? Okay, 4/10 repeating. So what number is understood after the first 4? A 0. So which one is clearly greater? So which park is that? Badlands. Make sure that you actually answer these questions tonight. This is your work. This is not your answer. Your answer is Badlands, and your work is shown by converting both fractions to decimals. Does that make sense? Your answer is Badlands. You have to answer the question. And then your 2 problems tonight, just make sure you actually answer the question. All right, moving on to example 4. In example 4 now, we're going the other way. We're writing decimals as fractions. Well, there's 2 types of decimals that we've already learned. Terminating and repeating. Where's my terminating? Or, no, I was looking for repeating. Oh, there it is. Okay, yeah. Example 5 shows a method for writing and repeating decimals as a fraction. I am not a fan, and you can just ask 6th hour how it went. It did not go very well, of their method of showing, of finding a repeating fraction. So I'm going to just teach you how to do it using your calculator. For the terminating decimal, I do want you to understand place value here and how we get the denominator. What place is the 7 in? It's in the 10th place. So that's how we come up with our denominator. All right? So on the second one, what is the place value of the last digit in the decimal? Hundreds. So don't forget your negative. Negative 3 and 5 over 100. Do you see how I'm doing that? Okay? You can do all of this on your calculator. Okay? But I want you to understand the reason why behind it. Now, your final answer must be in simplest form. 5 over 100 can be reduced to what?
1 over 9.
And that would be my answer. Okay? I want you to try the last two. All right, guys, so what's my fraction in number 3? Negative 2 over 1,000. And then I reduce it to negative 1 over 500. All right, don't forget your negative. Then we've got 1 and 62 over what?
100.
Yep, and then we reduce it. 1 and 31 over 50. 31 over 50. All right, so you've got an entire section, guys, of just this. However, sometimes it's a repeating decimal. Sometimes it's a repeating decimal, like, let's see, example 5. Now, in example 5, I'm going to just go ahead and take out this method right here. Okay? We're not gonna use this method. I want to teach you how to find this using your calculator. So you need to go ahead and enter the decimal. Just hit the decimal button on your calculator, then hit the alpha button. The alpha button and the square root button. That should put in the repeating bar, and then enter that repeating decimal, 93, and hit equals. The alpha and then the square root button. What did you get?
I got 31 over 33. I got syntax too.
Okay. 31 over 33 should be your answer. Help your neighbor find the button. All right, 0.75 repeating is what?
25 over 33.
Very good. And then 0.33?
1 over 3.
Very good. All right, guys, so we're taking the short way out, but that's okay. That's okay. We're just going to use our calculators on that one. Cole?
I see a thing repeating through all of them that, except for the third one, which is simplified, they're all 33.
It very well could be a common denominator with repeating decimals. All right, now one more example. In example 6, okay, we're ordering these least to greatest. The problem is that we need them all in the same format, so we need them all as decimals. All right, so the fractions that you see, you need to go ahead and convert to decimals first, and then we can put them in order least to greatest. Okay, so 5/4, negative 5/4 becomes negative 1.25, negative 0.2, 4.31, negative 3, 2.5, and 4.33. It was a 3 repeating. Why did I do 2 3s? Why not 3 3s? Did I need 3? No, because the other decimals only had 2 digits. All right, so now I can clearly see, write it in the original format, which one is the lowest? Negative 13 over 3. I can clearly see that this one is the lowest value, but I have to write it in its original format in my answer. Negative 13 over 3. I want you in the original format to put them in order, least to greatest. Okay, so what's the next smallest number? And then? Very good. And then? And then 5 over 2, and then 4.31. You have 2 of these on your homework tonight. Okay, if you understand that, that's everything you need to know for 5.1.